Welcome to your next challenge. It's now your turn to apply the skills you just learnt about DDL, prepared statements, transactions, and batch processing. You should start with the JDBC challenge project from that challenge, but create a new class for this code. First, I want you to change the structure of the order_details table, adding a new column called quantity, a number. I'm purposely not telling you which DDL command to use, since this should be easy to look up. Once you've made this change to your database, you'll proceed with adding data. Use data from orders.csv to add orders to your storefront database. I've included this file in the resources folder to use as input. This file contains information for 5 different orders. The format of this file is different from the last video, so be sure to study it a little bit so you know how to read it. Use prepared statements to insert each order and its related items. Batch up the line items for each order, but batch only line items for a single order. Use a transaction for each individual order, rolling back the order insert if something fails, but allowing other orders to be inserted. Okay, so pause the video here and go away and give that a try. When you've got it done, or you get stuck, come back and we'll walk through my solution together. Welcome back. I hope you found that challenging, but were able to make good progress. I've got the project JDBC Challenges open, and I've created a new class, which I've called Challenge 2. I'll start by copying the main method from the main class in this project, pasting that in my new class. I'll remove all the code in the try block. Next, I'll set up an alter table statement. Hopefully you were able to research that and found that the way to change a table in the database is to use the alter DDL statement. In this case, I'll alter storefront.order_details and add column quantity int. There are options you can include for the column, but let's just keep this simple. Next, I'll get a statement and call execute, passing the alter string. So you might be asking why I didn't use a prepared statement here. In general, you don't use prepared statements for data definition language or DDL statements in Java. Prepared statements are typically used to execute data manipulation language or DML statements where the same SQL statement may be executed multiple times with different parameter values. DDL statements, on the other hand, like this one, wouldn't be run twice and you wouldn't get the benefit of the precompiled statement. Let's run this. If you haven't already done so, don't forget to set your environment variables for the MySQL user and MySQL password in the run configuration for this class. Now, there's no output, but we don't get an exception either. I'll open my SQL workbench and choose the development session. In the schemas panel, I'll expand the storefront database, then tables, and highlight order_details. This time I'll select the info icon and then select the columns tab. Here you can see that quantity is now a column in this table. I'll go back to my Java code. We only have to do this once, so I'll now comment out this code. So next, I'll write the code to read the data from the file that has the order data. Let me open this file a minute. In this file, the order data has the keyword order in the first column, whereas the details have the keyword item in that column. Notice that the order records have dates already formatted the way we want them to be. Also notice, the time changes by 1 minute. You can use this to recognize the orders. I'll use a different approach in this code just to show you an alternative. First, I'll set up 2 records, one for order and one for order details in the challenge2.java source file. I'll start with the order detail. This record has 3 fields: order detail ID, an int, the item description, a string, and quantity, an int. I'll create a custom constructor for this because I won't have an order ID as I'm reading the data in from the file. So I want a constructor with just item description and quantity. And this has to call the canonical constructor, so I'll pass -1 as the ID. Next, I'll create a record for the order. This will have order ID, date string, and list of order details. And this one will have a custom constructor too for just the date string. So when I call the canonical constructor, I'll pass -1 for the order ID, and I'll create a new array list for the details here. The only other thing I'll add is an add detail method that'll take an item description and a quantity. I'll create an instance of the order detail, pass that the description and the quantity, and I'll add that to the details array. Now that I have types to put the data in, I'll write the read data method. This will return a list of orders. I'll initialize an array list of orders to start with. This time, I'll use a scanner. If you used files or some other method, that's fine. I'm really choosing this method just to remind you that you can use scanner to read data from a file. I'm putting this in a try with resources block. Unlike files.readlines, the scanner won't get closed automatically, so if I put it in this type of try statement, I don't have to remember to close it. I'll set the delimiter to be either a comma or a new line. This means, instead of splitting the data by line, it's going to split the data by commas. I'll create a list of strings by calling scanner.tokens. That gives me a stream of strings, so I'll use map to trim each value, then terminate the stream, collecting it into a list. I'll print each value in my order list. Then I'll return my order list from this method. This won't compile, so I'll use IntelliJ to add a catch clause. Obviously, I'm not done yet because I have to create the order and order details. I'll loop through every column value one at a time. I'll get the column value from the list. If that token has the value order, then I know I need to set up an order. The date is the next place in the list, so I'll do a pre-increment, then get the next value. I'll create an order and add it to the order list. Similarly, I'll check for the keyword item, which indicates the tokens that follow are item fields. I'll pass the next field, the quantity. Now, in a normal world, you'd want to do more validation, but again, I'll just keep this simple. The item description is next. I can get the order that goes with the details by just getting the last order added. Then I'll add the detail to that order. I'll test this code out by calling this method. I'll insert a call to this method before I open a database connection. So first, I'll create a list variable called orders and assign that the value of read data. I'll run this now to make sure I get each order as a coherent unit. And you can see this code has 5 orders and all the information is stored now in this array of orders. Next, I'll create the add order method. This method will take a connection, 2 different prepared statements, and an order. I'll set up the prepared statements outside of this method so they can be reused. This will throw an SQL exception. Here, I'll use a regular try because I don't want to close any resources if this code fails. Instead, I'll be ignoring the error and continuing to process other orders. I don't want the code in this method to be part of a single transaction, so that starts by setting auto commit to false. I'll leave some space for the code here. I'll end the try block with a commit statement. I'll catch the SQL exception and roll back any changes if I do get one. Then I'll rethrow the exception. And I do want a finally clause because I want to be sure auto commit is set to true in any case. That's the setup for a transaction. Between the first auto commit and the commit method, I need JDBC code, so I'll start by initializing an order ID variable to -1. I'll now set the only parameter on the prepared statement for the order. I can use setString even when the field is a date time field. I'll call the execute update method on that inside an if condition, checking to make sure only one record was inserted. So if that's true, I know I can get the generated keys from the prepared statement. And you've seen me do this often enough, so I'll just get that and print it out. Next, I'll add the code to batch up the details for each order before executing the whole batch. I'll insert this code in the nested if. If the order ID is greater than -1, then I know my order, the parent record, was created okay. I use the prepared statement for detail, and I'll set the order ID, which is the first placeholder. Now, I'll loop through the order details and set the second and third parameters, that's item description and quantity. I'll call out batch on that prepared statement. After I've batched up all the statements, I'll call execute batch, which returns an array of integers. Now I'll sum those values up with a quick stream, which I did in the last video. I'll check if the rows inserted is different from the size of the details. If they are different, I'll throw an exception. Did you notice something here? That I set the order ID outside of the loop. Because I'm reusing the prepared statement, the parameters I used previously are still set, so here I can just set order ID once and it will stay set. The other thing is that I didn't set the flag on the connection, the set continue batch on error flag. This makes this code a little less efficient, so if you did add it, that's great. I'll just mention it, but I'll leave the code as is. We're almost done. I need a method which I'll call out orders. That'll take the connection and the list of orders. I'll set up a string for the insert order. Now don't forget, you need to specify parameters with a question mark and not a string specifier. I only have one placeholder, and that's for the order date. And I'll set up the string for insert detail, and that's very similar, but it has 3 placeholders. I'll use a try with resources, creating my prepared statements here. So PS order is the prepared statement for the insert order string. For prepared statements, I specify if I want generated keys back at this point and not in the execute update method. I'll create PS detail the same way. This won't compile, so I'll have IntelliJ generate the catch clause. Now it's time to put it all together. I'll loop through the orders using for each and start a multi-line lambda. I'll include a try catch clause in this lambda. I'll execute add order, passing the connection, the 2 different prepared statements, and the order. Here, I'll catch the SQL exception because I want to handle it and continue processing. And just to reinforce some of the lecture material, I'll print the error code, the SQL state, and the message. I'll print the state of the prepared statement for the order. And I'll print the order itself. Finally, I just have to call this from the main method. I'll add this inside the try catch clause. And that's that. I'll run that. So what I didn't tell you in the beginning was there was an error in the data. I did this on purpose so it would test the requirements of this challenge. The challenge was to make sure the order would be rolled back, but orders after the bad order would still get processed. So you can see the problem was with the 4th order, and that's because I had a bad date there. This format is the year, the month, then the day, so I have November 31st here, which isn't a valid date. You can see the MySQL error code was 1292, the SQL state code was 22001, and the message says incorrect datetime value. And then the prepared statement for the order is printed out. That's followed by all the order information. I'll switch back to MySQL Workbench and look at this data there. I'll highlight order and then pick the grid icon. Here, you see 4 orders added, which confirms the Java output. I'll do the same for the order details. And you can see order details for those 4 orders. So hopefully you got a lot out of this challenge. There was a lot to it, I know. This challenge included a DDL statement, prepared statements, batch processing and transactional processing. In the next video, I'll be talking about using callable statements, which are used to call server-side methods or functions, which are sometimes generically called stored procedures in a database. So I'll see you in that next video.